Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GMAT out of this book here, the GMAT Review, the official guide. If you do not have this book, buy it immediately. You will find it at mba.com. The problem that I'm about to solve is the one that you will find on page number 174, problem solving, number 165. Let's take a look at it. It says, during a certain season, a team won 80% of the first 100 game. All right. So they won. Oh, let me not use the red pen. Red pen is difficult to read. They won 80% of the first 100 game. Won 80% of first 100 games. Then we are told that and 50% of the remaining games. Won 50% of the remaining games. Alright, so far so good. If the team won 70% overall for the entire season, if their winning streak was 70%, what was the total number of games that the team played? What was the total number of games that the team played? That's the punchline. What is the total number of games? Obviously, it's an algebraic problem. You can solve it with the algebra if that's what you wish, if you're very good at algebra, if you know how to set up the equation. Setting up the correct equation for the algebra is the biggest hurdle. That's the part that gives most people trouble, the people who are not very good at algebra. If you happen to be one of those people, I'm going to show you here how to solve this thing without the algebra, and we'll see what happens. You see, there are answer choices are numerical. The question is, how many total games? What was the total number of games that the team played? What was the total number of games that the team played? Obviously, the answer is numerical. There are 5 answer choices there, and my logic is that instead of solving this thing out properly and then seeing which answer agrees with my answer, I say to myself, the correct answer, whatever it is, it's got to be one of these 5 answer choices. It has to be one of these 5 answer choices. Let's write them down. A, B, C, D, and E. 180, 170, 156, 150, and 105. I said to myself, why should I waste my time trying to solve this whole thing? Why don't I take one of these numbers, put it back in the problem, and see if it works? If it works, I'm done. Great, I get lucky. If it doesn't work, I'll try something else. Question is, where should I start from? Should I start from A? Should I plug in the number in A, or should I plug in a number in E? The answer is neither. Do not start with the extreme. Start with the happy compromise. In the vast majority of the time, I was about to say always, but always is a very strong word. Almost always, when the answer choices are numerical, they are arranged in a numerical order. They are arranged either in the ascending order or descending order. Very rarely they are mixed up together. See, here they are arranged in order. So start with the happy compromise. It doesn't matter whether they are arranged in ascending order or descending order. Happy compromise is the middle number, which is C. I start with that and see what happens. If C fits, if it works, I'm done. It fits, answer is C. If it doesn't work, in majority of the cases, in majority of the time, you should be able to tell whether that number is too small or too big. For example, if I try C and it turns out that it is too big, right away I have narrowed down my odds to 50-50. If this C is too big, that tells me that C is wrong and so is B and so is A. Answer has to be one of these two. And then you try one of these two numbers. If they fit, you're done. If it doesn't fit, then you know the answer is the remaining one. That's it. You only have to try twice. So I'm going to start. Now what I'm about to say, this part, the part that I'm about to start right now, is going to sound pure insanity to you probably, but I'm just honest to truth. I'm telling you what happened to me when I was solving this problem. When I solved this problem for the very first time, this is my logic. I start with C, but in this particular case, I did not like that C. That C, I wasn't too keen on it. It's an odd number. I don't like it. I like nice round number, 150, 170, 180. So ordinarily I start with C, but I don't know what possessed in me. I started with D, just for the hell of it. I didn't know what was the answer. I had no idea what the answer was. I pretended that the answer was 150. If that's the case, then we know that they won 80% of the first 100, that's 80, and then they won 50% of the remaining. If they played a total of 150 game, 50, that means the remaining game that they played was 50. Half of 50 is 25. And that comes out to be 105. Let's see what 105 works out to be as a percentage of the total number of games. This has to be 70%, we'll see. I was immediately suspicious. You should know your table of 15, it's very handy in the exam. And if you don't know it, just do it out. You see, 15, I know 15 times 10 is 150 obviously, and half of 150 is 75, that I know. So I know that 15 times 5 is 75. If I add another 15 to it, that's going to give me 90. And if I add another 15 to it, that's going to give me 105. You see? This number represents times 6, and this number represents times 7. 15 times 7 is 105. There you go. This is 7 over 10. It is 70%. Which is exactly what the problem tells me that they have. They have an overall winning of 70%. And I was done. I just got lucky. Now if it turns out that when I did all this calculation and this number is not working out to be 70, it turns out to be more than 70, that would have told me that I need to reduce this number. I need to have a smaller number. I would have tried that, and then I would have known that the answer has to be this. If it turns out that when I did this ratio and this is less than 70, that tells me that they have to win more games. The only way they can win more games is if they played more games altogether. So I would have tried one of the other two. But anyway, I happened to start with D and I got lucky, that's all. But that's the logic. Now let me show you the classical way, the algebraic way. I should leave this here. I'm going to leave that here, or maybe not. 105 over 150 is 7 over 10, because 15 goes into 105 7 times, and that's 70%. Let's do the algebraic way, the classical way, the proper way, in a way that will make your math teacher proud. So I know that they won 80 game out of first 100. 80 game out of first 100. Then they won 50% of the remaining game. I'm calling the remaining game X. If that is the number of remaining games they played, then the total number of games that they played, let's call it R instead of X. R for remaining games. R for the remaining games. There you go. And that ratio, we are told that the overall total is 70%. This has to be 7/10. I don't write 70% as 0.7 because that makes the life annoying. Just write it down as 7/10 because it's easier to multiply by 10 and the 7 than it is to multiply than it is to deal with decimal. I don't know why people have this nasty habit of writing everything in decimal. Keep it in fraction, it makes life simpler. So let's cross multiply, okay? That's all we have to do. I'm going to cross multiply. So I end up with 10 times 80 plus 0.5 R has to equal 7 times 100 plus R. 10 times 80 is 800, and 10 times 0.5 is 5, so that's 5R, and here I get 700, and then 7R. You see, simple, straightforward. Subtract 5 R's from both sides and you're going to end up with 2 R's equals, and then subtract 700 from both sides, 2 R's equals 50, 2 R's equal 100, and R equals 50. R was our remaining games. I'm using R for the remaining games. And since if the remaining game is 50, altogether they played 150 games because we are told that they won 80% of the first 100 game. Let me take a look at the camera here for a second. Over 9 minutes. I gotta wrap this thing up. So that's all. That's all it is. I hope you found my logic. I hope you've understood my work. I'm going to rewrite this equation one more time very quickly before I complete run out of time so that you can see it clearly. They won 80 games out of the first 100 games, and then I'm told that of the remaining game they won 50%. So that's where my 0.5 comes from. They won 50% of the remaining game, and the total games that they played must be the 100 game that they played originally plus however many remaining games they played. And that overall ratio has to be 70%, we are told, 7 over 10. And that's where I come up with that equation. And once you have that equation, you just cross multiply and solve for R as I just did. I hope you found this helpful. If you wish to purchase my DVDs in which I show you the solutions to all the math problems, or if you wish to hire me for personal private tutoring, in either case, go to my website at www.prep4gmat.com. Thank you.